Assalamu alaikum. This is Uzaifa Saleh, and today we will learn about bending moment and shear force diagram of beams and how to solve a beam if it is under the subject of point load. So here is the question. In such questions, first of all, we have to make free body diagram. I am showing the beam with a line. There are two forces and two supports. The supports would have reaction forces on them, which are Ra and Rb. Write the distance between forces. Now we have to apply equations of equilibrium on the system. If a body is in rest, it must satisfy the equation of equilibrium. Why we are doing this? To find the reaction forces. Sigma fx is equal to 0. As beam is in rest, so sum of all forces in this direction must be equal to 0. In the case of our beam, there is no force in the x-axis. Sigma fy is equal to 0. We will write downward forces one side and upward forces on the other side and solve it. I am considering point A pivot. The moment around A must be 0. There would be no moment due to Ra force. 6 kN force is trying to rotate the beam clockwise. Clockwise moment will be written on one side and counterclockwise moment will be written on the other side. We know moment is equal to force into distance from the pivot. By solving these two equations simultaneously, we will find the value of Ra and Rb. The next step is to slice the beam into different parts and read the effect of forces on these parts. We are cutting the beam for the distance from A for which x is greater than equal to 0 and less than 5 meter. Means we can cut anywhere up till the point where 6 kN force is applied. I have drawn this segment isolatedly. In this segment, there is no force other than the Ra. Whenever we cut a beam, there would be internal stresses, so we have to consider them as well. The internal stresses includes a bending moment MO and a shear force V. How we decide the direction of these forces? Shear force must try to rotate the beam clockwise around the pivot point. In this case, it would be taken positive. The bending moment will be positive if its arrowhead is on the upper face of the beam. Now we have to solve this system. Again, we have to apply equations of equilibrium. Ra is not producing any moment where MO and moment due to V forces are opposite. The distance from A to V is x. Now we are going to cut the second section. This times x greater than equal to 5 and less than 15. I am drawing the free body diagram. As we have cut it, there would be internal stresses. Again apply the equation of equilibrium. MO will rotate the beam anti-clockwise and V will rotate it clockwise. If you see, there is another force 6 kN which will rotate it clockwise. The distance between point A and 6 kN force is 5 meter, where the distance between point A and V force is 5 plus x meters. And by solving it, we have these values. In first section, we have taken origin point A. But in last section, we are taking origin point B and will go away from it. For it, condition for x is x greater than equal to 0 and less than 5 meters. Shear force will be positive if it is trying to rotate the beam clockwise, so I have taken its direction upward to make it positive. To make bending moment positive, the direction of the MO would be such that its arrowhead is on the upper face of the beam. Now apply the equations of equilibrium. We will get V is equal to minus RB. So V is equal to minus 9. And MO is equal to 9x. There were 3 segments of given beam and we have solved each one. Now we have to draw shear force and bending moment diagram. First of all, draw the beam as it is given in the question. At every marked distance or the section you have sectioned the beam, draw vertical lines and mark the distance between them. It is 0 axis line for the shear force and it is 0 for bending moment. As it is first segment, so we will see the first segment values. For it, V is equal to 7 and it is purely constant. It will be 7 throughout the first segment of the beam. Now for the second segment, V is equal to 1 kilonewton. So 7 will decrease to 1. In third section, V is equal to minus 9. So it will decrease 1 to minus 9 below the 0 line. In the video, it is plus 9 due to the error in calculation. Now move toward the bending moment diagram. For the first section, it is 7 into x, and x is distance from 0 to 5. At this point, x is equal to 0. So MO is equal to 0. As the value of x will increase, MO will increase 0 to 35 for the first segment. For the second section, MO is equal to 35 plus x. For second section, at this vertical line, x is equal to 0 and it increases 0 to 10. That way, MO will increases 35 to 45. Next is third section. For it, MO is equal to 9 into x. If you recall, for third section, we choose point B as pivot. So at point B, x will be 0 and will increase left to the point B from 0 to 5. Hence, MO increases 0 to 45 left to the point B. There are some hints for bending moment diagram. Bending moment graph never goes in negative region. Second, if there is x square or higher power of the x in MO in the expression for any section, then graph will increases or decreases in curvilinear manner. If you find this video helpful, please like, subscribe and share this video.